those little mud crabs saw me, and they heard me, and they're quite a good ways away. So that shows you that they have a good defense system. Of course, there's an echo underneath the bridge, but I was walking down the dock, and they might have also felt the vibrations because there's possibly vibrations from walking on the dock. But I think mostly they saw me and heard me, which is really surprising that they can hear so well. I'm not exactly what their hearing is like, if their body just senses the acoustics. I don't know, but they were all right down here in the water, and I was just walking along, and they all scattered up into the grass. I didn't realize they had such good senses of, well, I know that crabs can see pretty well. I don't know if they see a distinct image or they see more of just the light changing, but crabs do seem to be able to see pretty well. But the noises, hey crabbies, they think they all feel safe now. You can still see them down there. See, they see me moving. They were like, we know how we get eaten. You think I'm a great big herring. There's a lot of them. I don't remember seeing those little mud crabs like that so much when I was younger. Things go in cycles, I guess. But I see a lot of them nowadays. Well, it's another summer day. It's a little bit hazy today. We've had a streak of some hot weather for the last few days, and the wind has been fairly calm. I mean, just a little breeze, and that little breeze makes a huge difference. Right now there's just a little gust of wind. It really helps cool things down, but it's not enough to really give relief. But and even the rain showers have been kind of spotty, not enough to really cool things down either. I suspect though it's looking pretty overcast, so we might get some substantial thunderstorms. There's several days of this kind of heat. What that does, it makes a lot of water evaporate and go up into the atmosphere, and that water goes way up into the atmosphere, and it condenses, and because it's colder up high in the air, and then it falls as rain, and then the water droplets are cooler, but they're also a liquid. And so when that liquid comes back down to earth, and it starts to evaporate back off, at first it makes things real hot and muggy, but that phase change from liquid back to gas takes a lot of heat away, and it helps moderate things and keeps things from getting too hot. So it's a nice process and a nice cycle, and it feeds the vegetation, so things will get green. And you can already see there's a lot of this vegetation that's pretty dried out. It's not real bright, lush, and green like it was a week ago. These are drying out. The plants suck up a lot of the water, and then they help the water go back up into that helps the water go back up into the atmosphere, and it also gives moisture to the plants, which they need for their cells to work. Water is essential for life on Earth. I was reading, and I probably had heard this before somewhere, but I didn't recall it. And I was looking at some information about a lake in Africa called Lake Tanganyika, and Lake Tanganyika is in what's called the East African Rift Zone. It's a very ancient fault zone, and it's very deep. And Lake Tanganyika, even though that fault area has been there for, I don't know, 1 billion years, and it's filled up with a lot of sediment, it's still the second deepest lake on Earth, which is very surprising considering that it's had a lot of time to fill in with sediment, and it's still the second deepest lake on Earth. But when I was looking at that, I learned that there is a lake in Siberia, Russia, that's deeper than Lake Tanganyika and larger than Lake Tanganyika. In fact, that one lake in Siberia, which is also in an ancient rift zone, has more water, more fresh water than all the American Great Lakes combined. That is a phenomenal statistic. And apparently it holds somewhere between 20 and 25% of all the fresh surface water on Earth. Now that's surface water. There's fresh water under the ground too. But as far as the surface water, that means the water that is not salty or brackish, that is on the surface of Earth. So that would be all the lakes, and probably, I guess, include freshwater rivers too. It doesn't include the moisture that's in the air, and it doesn't include the water that's under the ground. But it holds like 20 to 25% of all fresh surface water on Earth. That is a crazy statistic for one lake to have that much volume. So if you've ever seen, or whenever you go see the American Great Lakes, they are humongous lakes. And to think that this one lake in Siberia has more fresh water than all the American Great Lakes combined is just absolutely mind-boggling. And but it's also a very deep lake. It's almost a mile deep. So the American Great Lakes, they may have some spot in them somewhere that's really deep, but for the most part they're nowhere near that deep. I don't know for sure. I mean, there's different lakes or different depths, but the American Great Lakes primarily formed from glacier activity, meaning that the lakes were carved out by ice, and then they were filled up when the ice melted. So, you know, those aren't as deep as like a rift zone. A rift zone is where the actual continental crust had separated, or had there have been tectonic activity there. So that means it could be very deep. And the deepest places in the ocean are on tectonic boundaries also. So the Marianas Trench in the Pacific, which is, I think, still considered, I think there's a little bit of back and forth on what is exactly the deepest point in the oceans, but I think that's still considered to be the deepest place in the ocean. And it's in a subduction zone, which is where one tectonic plate is going underneath the other. And so at that boundary, there's a it creates a, I mean, you're talking about going down and underneath the crust of the earth. And when that happens, that also takes a lot of water, starts carrying seawater down underneath of the earth's crust where it's molten. And that is why you can get that plays a role in volcanic activity. So the hot magma in thin areas wants to come up through the surface and come up out as a volcano, or as usually it's just called a volcano. We have a lot of different kinds of volcanoes, but I guess you can also have well, there's a few different geological features, but basically a volcano. And if that magma has a lot of water in it, from being, you know, from the water being carried under in the subduction zone, that can create a very explosive eruption because of the water boiling, you know, like under high pressure. And so just like, you know, when if you hold the lid on a tea kettle and it gets really hot and it wants to blow the lid off, well, it's way stronger than that. And all this water with the hot magma is trapped underneath there, and as it makes its way up to the top, once it can get through to the top, it explodes and makes a huge eruption. Nature, physics, science, it's all just so much, it's fun and it's wonderful, and it makes us think, and it's our planet that we're on and our universe that we're in, and everything's working, and we have explanations for things, but then it gets more detailed, and then it gets more detailed than that, and then there's a more detailed than that. So it's like all these levels that you can just keep learning and learning. And that gets back to set theory. So when you have a set and then another set of sets and sets of sets of sets, and that's how like categories are. So set theory is such a wonderful concept to think about because it covers so much. It's such a simple thing, but it helps us categorize and gives us a way to think about things. So like there could be one giant set. That set could be the universe. So everything is part of the set that is the universe, and you can describe that in mathematical terms, and you can describe that in qualitative terms. So set theory can apply to math, but it can also apply to qualitative things like let's say clothing. So clothing would be a big set, and then a subset of clothing could be like, it could be a lot of different things. You could do it different ways. It's up to you based on what you're trying to explain and understand. But let's just say there could be men's clothes and women's clothes and girls' clothes and boys' clothes and babies' clothes, and then there could be winter clothes and summer clothes and spring clothes and fall clothes, and there could be pants and shirts and dresses and skirts and on and on and on and on. And each one of those categories is a subset of the set of clothes. And so clothes is the set of all sets of clothes, and then the different categories underneath that. And then you can get into colors and sizes, and all of those are all sets. And then you can have combinations of sets. So that's mostly qualitative, but then there's quantitative, and that's when you have sets of numbers that are applied, where you're applying mathematical rules. So really, really, really neat way to think about things. And we naturally, intuitively kind of know it, but it's better to actually know that there's a theory behind that, behind set theory. And it helps really to understand things. And there's lots of other kinds of theories like that really help too, but that's a good one, set theory. So if you get a chance, just read up on set theory a little bit. They should teach it to you in school. I love you.